Hey everyone! Alright, today we're going to tackle something that looks super intimidating in algebra class, but I promise you it's actually incredibly simple once you know the secret. We are talking about adding and subtracting square roots. Let's just jump right in.
Okay, so look at this. The square root of 32 plus the square root of 8. Now, if you're like most people, your brain immediately wants to just add 32 and 8 and say, it's the square root of 40, right? Well, nope, doesn't work that way. I know it looks like a total mess, but hang on for just a couple of minutes. I swear you'll be solving this kind of thing in your head.
What if I told you the secret to solving this is something you already know how to do? Like you've been doing it for years. If you can solve something as simple as 3x plus 5x, you've got this. That's the big secret we're going to crack open today.
So that secret, it all comes down to one big idea: like terms. You know, it's that rule in algebra that lets you combine stuff, and guess what? It is the exact same key we need for these crazy-looking square roots. Okay, just look at this side by side. On the left, basic algebra. 3x plus 5x is 8x. We all know that. You combine them because they're like terms. Now look at the right. It is literally the same logic. Think of the square root of 2 as just being your x. So 3 square roots of 2 plus 5 square roots of 2 gives you 8 square roots of 2. See? It's the exact same pattern. And that brings us to the key phrase here, like radicals. All this means is that the number inside the square root symbol, the radicand if you want to be fancy, has to be exactly the same. If they match, you're good to go. You can combine them. If they don't match, you can't touch them. It is really that simple. Okay, so this leads us to the heart of the whole thing, a super simple two-step method that will work every single time. This is your golden rule for adding and subtracting radicals, period.
And here it is. Step 1, and listen up because this is the most important part. You have to simplify all the square roots first before you do anything else. Don't even think about adding them yet. Then, step 2 is the easy part. Once they're all simplified, you just go ahead and combine the like terms that you found.
All right, that's enough talk. Let's actually put this two-step method to the test, and you can see for yourself just how easy this is.
Okay, first one up, the square root of 7 plus the square root of 28. Now right away you're thinking, wait, these aren't like radicals. One's a 7, one's a 28, and you're right. But what's our golden rule? We have to simplify first.
So let's just zoom in on that square root of 28. We need to find a perfect square that's a factor. And yeah, 4 works. 28 is just 4 times 7, so we can break that apart. The square root of 4 is a nice clean 2. We pull that out front, and the 7 gets left behind inside the root. Boom! The square root of 28 is just a cleaner way of saying 2 times the square root of 7.
Okay, so now let's go back and rewrite our problem. We have the square root of 7, which is really just 1 square root of 7, right? Plus our new simplified version, which is 2 square roots of 7. And would you look at that? All of a sudden, we've got like radicals. They both have a root 7.
And now that we have like radicals, it's just like adding 1x plus 2x. We just add the numbers out front. 1 plus 2 is 3. So the answer is 3 square root 7. See? It's that simple. Simplify, then combine.
All right, you ready for this? Let's circle all the way back to that first puzzle, the one that looks so impossible. Square root of 32 plus the square root of 8. Now that we know the two-step rule, this thing doesn't stand a chance.
Okay, step 1, simplify. Let's do root 32. We need the biggest perfect square that goes into it, and yep, that's 16. So root 32 is the same as the square root of 16 times 2. The square root of 16 is just 4. So this whole thing simplifies down to 4 root 2.
Now for the other one, the square root of 8. Perfect square that goes into 8, that's 4. So we have the square root of 4 times 2. Square root of 4 is 2. So that becomes 2 root 2. Easy.
So now let's plug our simplified pieces back into the original problem. That ugly-looking root 32 plus root 8 is now a much friendlier 4 root 2 plus 2 root 2. And just like that, we've made ourselves some like radicals.
And from here, it's a piece of cake. 4 plus 2 is 6. The answer, the final answer to that big puzzle, is 6 root 2. So clean, so simple.
And you know this whole simplify then combine thing, it's not just for these kinds of problems. It's like a universal law. It works for everything, even when you start mixing in regular numbers or, get this, even imaginary numbers.
Check out this table. It shows exactly what I mean. Look at the first row. We simplify the square root of 16 to just 4. Now we have 3 plus or minus 4. Those are both just numbers. They're like terms, so we can combine them to get our answers. Okay, row 2. We simplify the square root of negative 25 to 5i. Now we have a real number, 3, and an imaginary number, 5i. Those are not like terms, so we just leave them. That's the answer. And in the last row, we simplify root 48 to 4 root 3. Now we have negative 4 plus or minus 4 root 3. That's a regular number and a radical. They're not alike. Just like you can't combine negative 4 and 4x, you can't combine these either. See? The rule always works. Simplify first, then only combine what matches.
All right, let's bring it all home. If there's one thing you walk away with today, this is it. Let's make it crystal clear.
Here it is. First simplify, then combine. That's it. That is the only rule you need. If you're ever looking at a problem with adding or subtracting square roots, just say that in your head. It's your mantra, and it will get you to the right answer, I guarantee it.
So yeah, that's the whole game plan. Step 1, simplify everything you can. Step 2, look for your like terms. Constants with constants, matching radicals with matching radicals, and combine them. That's all there is to it.
And really, just like that, you've taken something that looks super complicated and turned it into a simple, two-step process you can do over and over again. You've just mastered a really important algebra skill, seriously.
But before we go, here's a little something to think about. We've totally nailed addition and subtraction, but what happens if you have to multiply? What if you had, say, the square root of 3 times the square root of 12? Is the rule the same? Do you still simplify first? Or is there a completely different secret for that? Something to think about. Thanks so much for tuning in.